right, there we go. All right, so if you're in your note guide, there's a page for solving. If not, just continue your notes right where we were for solving. So we see the denominators. Because they're not all numbers, do you guys see how it would be hard for me to start subtracting things and try to isolate y? Y is in more than one spot. It's not the same denominator in the spots that it's in. That's your hint that you probably want to use a least common denominator to cancel out the fractions rather than try to deal with the fractions, okay? So if we want to find a least common denominator, the first thing we're going to approach is going to seem very similar to yesterday, even though we're doing a totally different thing. So when I look at this and I want to approach it, I do want to still find the least common denominator, even though we're doing it using it for a totally different purpose, right? And so to find the least common denominator, I want to make sure all the denominators I have to look at in the problem are factored first. So this one, 3y plus 6, is not fully factored. I'm going to factor out the greatest common factor of 3 so I can see it in its factored form and have some idea of more like what they already have in common. Okay? So when I look at the first denominator, it has one factor of y plus 2. I need to include that factor as part of my denominator. When I look at the second fraction, it has 15. I can think of it as 15 or as 3 times 5. So I'm just going to write it like this way for now so I can see what's included in 15. It is a 15. Just broke it down to see. Neither of those factors were already in the denominator, so I put them in. And then my last denominator has a 3 and a y plus 2, but I've already accounted for a 3 and a y plus 2. Okay? So I've covered everything here I would need for a least common denominator. But now in this case, rather than making a common denominator, I'm going to try and cancel out the common denominator. So I'm using it a different way, right? I have an equation. I'm going to multiply both sides of the equation by this LCD, okay? So I'm going to take, and I'm going to write it this way, and then I'm going to write it out for you guys. I'm going to multiply everything by these factors. And if you don't want to write 3 times 5, we can write it as 15. I'm just trying to emphasize the factor rule here. But then I'm also going to multiply this side of the equation. This is the only reason why it's okay, is because there are 2 sides to this equation, things I already knew were equal. So what that means is the first fraction, 3 over y plus 2, is going to be multiplied by 15 times y plus 2. The second fraction, 7 over 15, is going to be multiplied by 15 times y plus 2. The fraction on the other side of the equation, 23 over 3 times y plus 2, is going to be multiplied by 15 times y plus 2. Okay, every part of that equation is getting multiplied by those factors. So now we want to look at each term of this equation individually, and hopefully we've picked a good common denominator so that we see enough stuff cancel out that we're dealing with a simpler equation in the fact that there aren't any more fractions. So when we look at the first term, that's now all of this stuff, okay, and remember what we're multiplying by didn't have a denominator, so it's like it's all in the numerator, and we can cancel, because it's multiplication, any common factors in both the numerator and denominator. So y plus 2 can cancel. Okay. Notice that leaves a denominator of 1. That's what we were aiming for. And so what's left of this term will be what we get when we multiply 3 times 15. Okay. I am going to write out a lot of steps here. So I'm going to write it like this. And then you guys, I know, already know what that is and stuff like that. That's fine. Just trying to emphasize the idea. The next term is right here. It has a multiplication problem currently in it. And the factors that we can see that can cancel are the 15s. So I can cancel those full factors of 15, leaving me with 7 times y plus 2. Then I have my equal sign. My third term is on the other side of this equation. The factor of y plus 2 can cancel. The factor of 3 cancels a factor of 3 out of 15, leaving a factor of 5. So I'm left with 23 times 5. And this is kind of what I was looking for. I was looking for a simpler equation. I know it doesn't look like how you always see it, but you can see there's no more denominator. There's a lot less happening. Now I have a much better chance at getting through the solving of this. So now I'm going to go through and multiply all the things that need to be multiplied. So on the left side, 3 times 15 is 45. And then I can distribute the 7 here. So I would get 7y plus 14. On the right side, 23 times 5, that's 15, is 115. And then I'm going to solve this like a linear equation. Okay? So the 45 and the 14 can be added together, so I'd have 7y plus 59 equals 115. I would subtract 59. And that should give me 56. Equals 7y, and then if I divide by 7, I'm getting that y is equal to 8. So pause for a minute before we talk about the little checking column that's in your note guide. Is everybody okay with what we did here? Do you see how it's different from what we worked on yesterday? The reason I keep saying that statement is because a big error that I see people make is because both these processes involve the LCD, you don't spend enough time understanding what you're really doing in each one sometimes, and you use an LCD, and I see people use it wrong in different contexts. Like they're using it like they should for solving in the subtraction problem, or they're using it like they would in the subtraction problem for solving, and they're getting confused on why they have so many things left. So I really want to emphasize that even though we're saying LCD over and over again yesterday and today, that we're using them in very different ways because we're doing very different things. Okay, yesterday we were adding and subtracting, today we're solving equations, all right? Is there anything here that you guys have questions on as we walked through that process? Okay, are there restrictions on the original problem? If somebody was just taking our original problem, okay, up here, and they were like plugging in different y values just to try them and see if they worked, like guess and check style for the equation, would they come across anything possibly that was undefined? Yes. When would they have gotten something undefined if they were trying to plug stuff into that original problem? Emily? Good, if y was equal to -2. So our restriction up here would have been that y cannot equal -2. So notice over here we're saying check. This is not like check because every thorough math student always checks their work. This is like check because when you do multiply through and cancel out that denominator, it's possible that when you made that new problem, that problem that has no fractions could solve for a solution that wouldn't work when there are the fractions in the original problem, okay? So when I say check, I'm really saying, in this case, check that y did not equal -2. If you did everything else right, now can you be more thorough and actually plug back in and check? Yes, okay, that's like a thing that we do in math, right? If we want to check our answer. But here we're saying this is not like I'm just encouraging you to check. This is you must check or you're going to leave answers that are incorrect. What are you really checking for? If you did all of the algebra right, you're really just checking that you didn't come up with an answer that wouldn't work in the original problem. Okay, so is 8 an okay answer to keep? Yeah, because it's not -2. Okay, is that all right with everybody? All right, let's look at example B. Okay, you guys try to start example B, okay? So can you find an LCD? Can you change the problem so that there aren't any fractions in it? And then could you solve from there? All right, is anyone confident in telling us what they got for that LCD? Maureen? Okay, questions from other people, because there weren't many people who raised their hand that said they were confident. Are you okay with choosing an LCD like this? So you're looking at a factor of 6 or 3 times 2, and then a factor of x minus 2. Okay, so if we take that and we multiply every piece of this equation by that greatest common factor, our work is going to look like this. So did you get for your first term that we would have 2 times x plus 1 if we were able to cancel out the denominator using that greatest common factor? On the right side, we would have 5x times x minus 2 being added with 1 times 6. Any questions at this step? All right, so then as we distribute things and put things together, this one's a little more difficult to solve, right? So we have 5x squared here minus 10x plus 6. So notice this is not a linear equation, it's a quadratic equation. So our options are like factoring, quadratic formula. We won't know which one of those to use till we get it set equal to 0. So I'm going to subtract these 2 terms so that I can set this quadratic equal to 0. See if it's factorable. If it's not factorable, try something different, okay? Did anybody get this far? Yeah? Okay, was it factorable?
Yeah.
Yeah? Okay, right. So what did it factor as?
5x minus 2. X minus 2.
All right. And so then that gives us 2 solutions, right? Our 2 solutions would be 2/5 and 2. Okay. And then this comes the part where, was the original equation that we were working with something that would have some restrictions? Is it something that at some point would be undefined?
Yes.
Yes. Okay. And so we have to look at what those undefined points are and make sure that we're not accidentally using a solution that would really be undefined when we plug it back in. So really when we're checking, we're looking for the restrictions. The restrictions here would be that x could not equal what? 2. Okay. And we got that as one of our solutions, right? So that's not actually a valid solution. You didn't do anything wrong. You did everything right. But when you took that step and canceled out the denominators, you changed the problem. And once the problem was changed, it has 2 solutions, but the original way it was written doesn't share both of those solutions, okay? So our final answer then would only be that x could equal 2/5. Okay, we would not include the 2. If it was the only solution you had and it was extraneous is what we call it, like you didn't do anything wrong, it just can't really be a solution, then you'd cancel that solution out and that means you would be left with no solution. Okay, so if you cross out the extra solutions and you're left with something, those are what you're left with. If you're left with nothing, you're left with no solution. All right? All right, why don't you guys go ahead and do the try this as well. Put it in sharing us what you used as the LCD. Brandon? Okay, so 2r plus 1 can't be factored. We have a 3. This 4r plus 2 can be seen like a factor of 2 and a factor of 2r plus 1. So is everybody okay with having a factor of 2, a factor of 3, or together 6, and then 2r plus 1? Okay, and so then I'm going to go through, we're going to multiply each thing by these. We'll make sure that I get the same thing that you guys got. And I know that I'm taking a lot of steps. Some of you don't feel that those steps are necessary. If you're not getting the problems right completely on the homework or when you take the beginning progressing mastery quizzes, the steps are necessary. Okay, that's kind of the thing. If you're getting them right every time because you're keeping good track of your work and it's organized, it's fine. If you're doing the shortcuts and you keep losing track, the shortcuts aren't helping you. Okay, so let's see what we get here. 6r plus 12, 4r squared plus 2r plus 9. Again, this is a quadratic. So again, I'm going to subtract these 2 terms so I can set it equal to 0 to decide if it's factorable or not and how I'm going to solve. All right, was it factorable? Yeah, what'd you get, Noah?
So 0 equals 2r minus 3 and then 2r plus 1.
All right, so this would give me solutions of 3/2 and -1/2. Okay. When we were doing our checking, do we have to eliminate any of these solutions? So which solution is what we call extraneous, meaning like we made an extra solution in the way that we solved the problem, not because we did anything wrong, just because we rewrote it in a different way, and that different way had more solutions than the original way. negative 1/2, okay? And that's because if we looked at our original denominators, right, they all broke down to having these factors in them. This factor would be equal to 0 and r is equal to negative 1/2. So that was our only restriction here, is that r could not equal negative 1/2. We see that in our solution, so we want to eliminate that solution and only let r equal 3/2.
Would it matter if you had factored it into 4r plus 1/2 into r plus 1/2?
No, you should get the same thing, but because you'll have fractions within fractions, you just might have to do a little more work or simplification. Okay? All right, is this okay with everybody? All right, so that's basically